All right, if you're a Swift developer, you know this is one of the first, most fundamental decisions you have to make. Are you going to use a struct or a class? It sounds so simple, right? But believe me, getting this choice wrong can seriously impact your app's performance, its efficiency, and even its safety. So today, we're going to break down exactly what this choice really means.
So let's just dive right in. How do these two fundamental building blocks actually change the way your app performs? When you're passing data all over the place, which one's going to be faster? Which one's going to be safer and less prone to weird bugs? And most importantly, how do you know you're making the right call for the job? Here's a quick look at where we're headed. We'll start with what I'm calling Swift's core dilemma. Then we'll look at structs, which I like to call the value copiers, and then classes, the reference sharers. Then we get to the really cool part, the copy on write twist. It's kind of like Swift's secret weapon. From there, we'll talk about making the right choice in your own code, and we'll wrap it all up with the final takeaway. Let's do it. Okay, so to really get into this, let's start with our first contender, the struct. Now, at their very core, structs are what we call value types, and that's because they operate on something called value semantics. But what on earth does that actually mean when you're staring at your code? It's actually pretty simple. It just means that whenever you pass a struct around, whether it's to a function or you're assigning it to a new variable, you're not passing the original. Nope. You are passing a complete, brand new, independent copy. Seriously, think of it like making a photocopy. You can give that copy to someone, they can scribble all over it, but your original document, it's perfectly safe, totally untouched. So let's just walk through this real quick. You've got your original struct sitting there with all its data. Then you decide to pass it to a function. Swift immediately goes, hold on, and it makes a brand new, totally separate copy of that entire instance and all the data inside it. The function then gets to work with this new copy, leaving your original completely isolated and safe. Okay, so the big question here, the one you're probably already thinking about, is performance. I mean, if your struct is tiny, with just a couple of properties, this copy is no big deal. But what if your struct is huge? What if it's holding a massive array or dozens of properties? Making a full copy of that every single time sounds like it could get really slow, really fast.
And that very concern, that fear of expensive copies, brings us perfectly to our second contender, classes, because they play by a completely different set of rules, something called reference semantics.
So if a struct is like a photocopy, a class is like sharing a link to a Google Doc. When you pass a class instance around, you're not sending the entire document. You're just sending a tiny, lightweight link, or a reference, that points directly back to the one and only original instance.
The process here is way simpler. You have one single instance of that class living in memory. When you pass it around to different functions or variables, all that gets handed over is a tiny little pointer, a reference. The actual data itself, it never moves. And this makes the whole operation incredibly cheap and super fast, no matter how massive that object is.
And this right here, this really gets to the heart of the trade-off. With structs, you make a copy. That means every part of your code gets its own unique, isolated instance, which makes it super safe from unexpected changes or side effects. But with classes, you're passing a reference, which means everyone is looking at and working on the exact same shared instance. It's definitely faster to pass around, but if one function makes a change, that change is instantly seen everywhere else, for better or for worse. Okay, so at this point, it kind of seems like classes are the clear winner for performance, right? I mean, passing a simple reference has got to be cheaper than copying a whole object. But hold on, because this is where the story takes a really fascinating and frankly brilliant turn. This is really the million-dollar question, isn't it? If you have a big struct packed with data, are you just automatically stuck with a performance penalty every single time you need to use it somewhere else in your code?
And the answer, thankfully, is a huge no. And the reason is this incredibly powerful optimization that's built right into Swift's standard library. It's called copy on write, or COW for short.
So here's the magic trick. Copy on write basically means that Swift is lazy, but in the best possible way. It puts off that expensive full copy operation until the absolute last possible second. It only makes the copy if and when you actually try to change or modify the data. And this isn't some obscure feature. It's the secret sauce that powers fundamental collections you use every day, like array, dictionary, and string.
This is so clever. Let's walk through how it works. So you pass a struct that contains, say, a big array. Initially, Swift doesn't actually copy the array's data. It sneakily just shares a reference to the data under the hood, kind of like a class would.
Now, as long as you're just reading from that array, no copy is ever made. It's super efficient. But the second you try to change something, add an element, modify a value, that's when Swift says, aha, time to make a unique copy. It happens right then and only then. This gives you the absolute best of both worlds, the safety of structs with the performance of reference passing for all your read-only tasks.
Okay, so we've got the full picture now. Value types, reference types, and the absolute magic of copy on write. But how do we turn all this theory into practical, actionable advice for the code we write every day?
The general rule of thumb in the Swift community is pretty clear. Start with a struct. Make it your default choice. You want to use them whenever safety and predictability are your top priorities, and when you want to avoid those really subtle, hard-to-track-down bugs that come from having shared, mutable state. They're just perfect for modeling data that represents a simple value. Things like a coordinate point, a color, or a user's profile information.
So that begs the question, when should you reach for a class? Well, you use a class when you explicitly want a single shared object that multiple parts of your app can all point to and modify. Think of things like a central data store or a network manager. Classes are also your only option if you need features like inheritance or you need to check for object identity. And of course, they are the right choice if you have a truly massive, custom data type that can't benefit from copy on write and needs the absolute fastest pass-by-reference speed you can get.
All right, let's wrap this all up. Let's bring it all home and put everything side by side for one last look at these really critical trade-offs.
This final scorecard really says it all, doesn't it? Structs make a copy when passed, which has a potential performance cost, but that cost is brilliantly optimized by copy on write, giving them incredibly high safety. They are your go-to for any kind of value-based data. Classes, on the other hand, only pass a lightweight reference. That's always low cost, but it comes with the risk of shared mutations, which makes them the specialized tool you use when you need to manage shared state.
And if there's one thing to take away from all this, it's the philosophy of the Swift language itself. Swift was designed from the ground up to encourage what they call a value-type-first approach. The guidance from the creators is clear. Start with a struct, and only move up to a class when you have a very specific reason to, like needing that shared state or identity.
And that really brings us to the final question, the one for you. With a much clearer understanding of these trade-offs, from value semantics to the incredible power of copy on write, how are you going to approach building your next data model? The choice is yours, and now you've got the tools to make that choice wisely.